Totally forgot to put that on there. Okay. So anything raised to the 0 power is going to give me 1. So look over here at problem number A. I've got 3x to the 5th, y to the negative 208, z to the 31st. The whole of this is in parentheses raised to the 0 power. And so that means that this simplifies to 1. And that's it. That's all I got to do. I'm done. It doesn't get a whole lot nicer than that. Questions? All right. So now let's look at part B here. I have 7 to the 0 power plus x to the 0 power. Well, 7 to the 0 power is 1, and x to the 0 power is 1. All right. Anything raised to that 0 power. So then I have 1 plus 1, and that's going to simplify to give me 2. Okay. All right. So part C is a little tricky. Somebody either say out loud or type in the chat, what is raised, and be careful before you answer this, what is raised to the 0 power in part C? What is raised to the 0 power? It is just the x. You were right, okay? So just x is raised to the 0 power. So this means I have 7 times 1, because x to the 0 power is 1. And so this answer is going to be 7. Do you see the difference between C and A? On A, I had everything in this parentheses was raised to this power. Here, I didn't have a parentheses, so just x was to the 0 power. If I had 7x in parentheses raised to the 0 power, then this would be 1. So just be very conscious and cognizant of what's being raised to the powers, and that's going to be kind of a huge concept with all of these problems, okay? All right. Next. Okay, so when we start to work with these exponents, there's some rules that we have to have. And one of the rules says that if I multiply like bases, I'm going to add the exponents. And I'm all about you memorizing the rules, but I'd like to give you a little bit of the why it works, okay? So I'm going to give you an example, and let's say I have x to the second times x to the third. This is pretty nice. Well, according to this rule, this should be x to the 2 plus 3 power. So it should be x to the 5th power. Well, let's look and see what x to the second is. So x to the second power is x times x. And then x to the third power is x times x times x. How many x's do we have? We have 5 of them, okay? And so that's the reason that we add the exponents if we multiply the bases, okay? As long as the bases are the same, life is good. Different bases, whole nother story, okay? So if you have like bases, you multiply them together, you can simply add the exponents. You just keep the base, it's going to stay the same, and add the exponents, okay? Now, when we look at part A here, we have some numbers that are multiplied along with our x's. And so the numbers we're going to treat just like we would multiply any other numbers. So this is going to be negative 7 times 6, which will simplify. And then we have x to the second times x to the 8th. And so this part is going to give me x to the 10th power. And then negative 7 times positive 6 is going to give me negative 42. And so my final answer here is negative 42 x to the 10th. And that's it. That's my final answer. Okay. Numbers times numbers, x's times x's. The next one, y's times y's. Okay. All of those good things. Okay. All right. So let's look at part B here. So I've got number times number. And so negative 5 times positive 5. And if you don't want to take this step in here, you don't have to, but I'm going to just for the fun of it. Okay. And then I have x to the second times x to the 6th. I like to put my x's together. And then I have y to the 7th and y to the 6th. Okay. And so the number part here gives me negative 25. Positive and a negative is negative. The x part here gives me x to the 8th, right? And the y is going to be raised to the 13th power. And that's my final answer right here. Very lovely. Questions, questions. All right, part C. You can do this a couple of different ways, but I'm going to tell you what they want you to do. They don't want you to pull out your calculator and do 3 to the 5th power and 3 to the 9th power. That is a big, gigantic number. It is bigger than a number I want to write, okay? At least to begin with, okay? So what I want to do is pretend these are like x's. So if I had x to the 5th times x to the 9th, this would become x to the 14th power, right? Okay, so if I have 3 to the 5th and 3 to the 9th, then this is going to be 3 to the 5 plus 9 power, which is the 3 to the 14th power. And that is a lovely answer, okay? Because I'm going to tell you, if you pull out your calculator and you do 3 to the 14th power, it's a big number. So if you actually punch this into your calculator, you would get 4,782,969. That's a big, giant number, okay? So that's, some of these problems are going to ask you to leave it like this, and some of them will ask you to come on and give a number for it. So just be aware of that. I would probably start by leaving those 3 to the 14th power because that's such a nicer way to write it than this big, gigantic 4 million number. Okay? All right. Multiply like bases, add the exponent. Divide like bases, we're going to subtract the exponent, okay? So here is kind of, some people teach this and some people don't. I like to do it this way. So where is the largest power of x? And so that's where I want to write my final answer. So if the power in the numerator is larger than the power in the denominator, I'm always going to subtract my powers. But if the power in the numerator is larger, then I'm going to put my answer in the numerator. If the power in the denominator is larger, I'm going to put my answer in the denominator. I'm going to show you what I mean. This is a little confusing, okay? So I'm going to start with this problem. And actually, I'm going to do you a simpler example. So bear with me just a second. I'm going to erase this. We'll come back to this. I'm going to do you kind of an example here and an example here. So let's say I have x to the 5th power divided by x to the 2nd power. So my power in the numerator is larger, and so I'm simply going to say 5 minus 2, and I get x to the 3rd power. Let's flip that over, okay? So let's flip that over, and let's do this as x to the 2nd power over x to the 5th power. So now my highest power of x is in the denominator, all right? So this is going to become 1 over x to the 5 minus 2 power. And 5 minus 2 is 3, and so I have 1 over x to the 3rd power. And so that's my final answer. It makes things a lot nicer if you can work with the fact that you're going to subtract and have a positive number. So that's kind of the end goal for these problems, is trying to figure out where my highest power is. And we'll see that in a couple of other examples too. But this is just kind of a real straightforward example for each of these. Okay. All right, so let's look at part A here. I've got numbers and I've got variables, so I'm going to split this up. So I have 4 over 8, and I'm going to simplify that. And then I have x to the 3rd over x squared. And if you can do all of this without splitting it up, there's nothing wrong with that. So 8 over 4. 4 over 8, 4 divides into both of those and leaves me with 1 over 2. X to the 3rd over x squared. My highest power is in the numerator, so I do 3 minus 2 is 1, and so this is going to be left with an x. Now, because I'm multiplying it by 1/2, I'm going to think of it as x over 1. And now I'm going to multiply straight across, and my final answer is going to be x over 2. Okay? If you didn't split this up, all right, you can simply think of this as, so if I've got 4x to the third over 8x to the second, 4 divides into 4 one time, and 4 divides into 8 two times. And so I can simplify it there. I can subtract 3 minus 2, and this is going to give me x in the numerator and 2 in the denominator. I get the same thing either way, just depends on how you want to break it down. Okay. All right, let's look at part B here. I have x's and I have y's, okay? Which of my variables is going to end up in the numerator when I simplify this? Only one of my two variables is going to end up in the top. So which of my two variables, either x or y, is going to end up in the top? Somebody tell me, either out loud or in the chat. Is x going to end up in the top, or is y going to end up in the top?
Y.
Yes, it is. Exactly. I got a verbal and I got a chat. Okay. So it's going to be the y, because y to the 6th power is higher than y to the 4th power. So 6 minus 4 is going to be 2. And when I look at my x's, the highest power is in the denominator. And so again, 6 minus 4 is 2, but my x to the second is in the denominator. And that's my final answer. I'm done. Questions? All right. So sometimes, though, we get stuck with these negative exponents. And so negative exponents really don't mean anything to us. Because if I tell you that an exponent tells me how many times I multiply something by itself, I don't know how to multiply something by itself a negative number of times. It just doesn't make any sense, okay? And so for that reason, I really need to get rid of the negative exponents, okay? So if I have something to a negative power, I move it to the bottom of the fraction. So you can think of it as moving it across the fraction bar is going to change that sign. So if it's in the numerator, I can move it to the denominator and I change the sign on my exponent. If it's in the denominator, I can move it to the numerator and I change the sign, right? So for these problems, we're going to rewrite these with positive exponents, and then we may need to still do some simplification. But the first thing we need to do is to get rid of those negative exponents. So this is 2 to the negative second power. It looks just like this problem. So the very first thing I'm going to do is I'm going to write this as 1 over 2 to the second power. And 2 to the second power, or 2 squared, is 4. And so my final answer here is 1/4. Questions? Right. Now, part B is a little bit tricky, but I'm going to show you the shortcut. Okay. We can write this as 1 over 2 2/3, and that hurts my head. So what I'm going to tell you is I'm going to make an amendment to this up here. So if I have, let's say I have, let's go a over b to the negative x power, this becomes b over a to the positive x power. Okay, so that's my shortcut. So that means that 2/3 to the negative second becomes 3/2 to the positive second. Gotta love it. There's always a shortcut in there when we deal with fractions. And so now I can square each piece and I get 9/4. And that is my final answer. Okay. So far, so good. We just don't like negative exponents. They don't help us any. All right, let's look at part C here. I have 3 to the negative first plus 5 to the negative first. I have to do these in pieces. So 3 to the negative first becomes 1/3, or 1 over 3 to the first. 5 to the negative first becomes 1/3. fifth, okay, or 1 over 5 to the first. Now I have to add these together, and I need common denominators, okay? And so I think I showed you this the other day when we were on the first day when we were talking about fractions, but if I didn't, I'm going to show you now. So here's my shortcut. I multiply these two together, so 3 times 5 in the denominator. If you're just adding two fractions, this is like the shortest, sweetest way to add fractions with non-common denominators. So multiply the denominators, do 1 times 5, and so 1 times 5 plus 1 times 3. So I take this times this number and this times this number. And so that's then going to give me 5 plus 3 over 15. And my final answer is going to be 8 over 15. And that is my final answer. That was not so bad. Questions. All right. So this next one has a combination of positive exponents and negative exponents. So the first thing we're going to do is we're going to get rid of the negative exponents. So that means we're going to move them. So everything that's negative is going to move with the exponents, right? The only thing that's going to stay where it was is this a to the second power in the denominator, all right? So I'm going to keep a to the second in my denominator. It's not going anywhere. So this a to the negative third power, I'm going to move to the denominator because I need my exponent to be positive. And b to the negative fifth power, I'm going to move to the numerator. And b to the negative fourth power, I'm going to move to the denominator. Okay? That's magic stuff. I understand that. But you can literally move things from top to bottom or bottom to top and change the sign of the exponents. Okay? And so now I'm going to clean this up and simplify this. So I have two a's in the denominator that are multiplied together. And so in the denominator, I'm going to have a to the fifth because I'm adding my exponents. I have a b to the fifth in the numerator and b to the fourth in the denominator. And I'm going to divide these by subtracting my exponents. And this is going to give me a b to the first power in the numerator. Now, one thing I do want you to notice is that I didn't put a first power on here. My exponent of 1 is an understood one. Okay? Questions? All right. So the next thing we're going to talk about, I said there's lots of rules for exponents. So the next one is if we raise a power to a power, we're actually going to multiply these exponents, okay? And so this is like saying I have lots of these. So if I have, so I'm going to give you kind of a short example. If I have x to the second to the third power, then this is the same thing as saying, well, I have x to the second times x to the second times x to the second, because I have 3 of these. That's what the exponent there means. Now, you know this rule. It says I add 2 plus 2 plus 2. But a shortcut way of adding 3 2's is to multiply the exponents, okay? And so that's why I could simply start here and say, oh, well, 2 times 3 is 6, okay? So a power to a power is a product. Okay, so an exponent raised to an exponent, we multiply those exponents. I like to say a power to a power is a product. Okay, so when I have something like this where I have multiple pieces, I have to raise each of these to that power. So what I'm going to do here is I'm going to multiply each of these exponents by -2. And so this is going to be x to the positive 4 and y to the negative 14. Now again, I don't like that negative 14th power. So in order to write this as my final answer, I have to take that negative 14th power, I have to drop it down to the denominator and write this as x to the 4th divided by y to the 14th. Questions? Powers or products? All right. So on this one, I've got several things happening here. I've got two different expressions raised to two different powers. Okay. So on this one, so you've got to think of this as a 6 to the first power. So here I had an x and a y. It made it a little bit easier. But think of this as a 6 to the first power. So I can still multiply those exponents. And so this first one is going to become 6 to the second power. Then it's going to become a to the negative 8th power because I'm multiplying those. And then this part is going to become a to the negative 8th power also because I have negative 4 times 2. Okay, so continuing to clean this up. So the next thing I need to do is say, okay, well, I know what 6 to the second power is. That's 36. These two a's are both raised to the negative power, and so I'm going to move those to the denominator. So this is going to be a to the 8th, and then another a to the 8th. And so in my denominator, I have a to the 16th power because I'm adding those exponents. And in the numerator, I have 36. And so my final answer is 36 over a to the 16th. Manipulating all of these lovely terms and their exponents. Questions? All right. So we're just taking it one more step, okay? And we do this piece by piece. The order in which you do these is not horribly important because all of this stuff is really multiplied and divided. I like to try to simplify the numerator before I try to go numerator to denominator. It's just kind of a personal preference. As long as you end with the same result, like I said, there's more than one way to get to the end on most of these. So on this numerator, I have 4xy all multiplied times y to the 5th. Well, the only things I can multiply together are the two y terms here. So this is going to be 4x and then a y to the 6th power, okay? In the denominator, I have 24x squared and a y to the 7th power. So as I look to simplify this, the first thing I'm looking at is the 4 and the 24. 4 divides into 4 one time, but 4 divides into 24 6 times. So in my denominator, I'm going to have a 6. Okay. Where's the highest power of x? Top or bottom? Highest power of x. I gotta wake y'all up a little bit. Highest power of x, is it in the top or the bottom? It's in the bottom. It is. So I have x to the first and x to the second. So I'm going to subtract, and so I'm going to end up with an x to the first and the bottom. Excellent. That's perfect. Okay. Now, where is the largest power of y? Not a trick question. It is also in the bottom. Okay. So I have 7 minus 6 is going to be y to the first. Well, what am I left with in the numerator? Don't anybody say 0. This is not 0. If I divide everything out of any expression, what I'm left with is 1. So please be careful of a problem like this. If everything divides out, I can't write 0. I am left with something, and I am left with 1. Okay? All right. Yay, fun stuff, fun stuff. Okay. So again, I need to simplify on part D here before I start doing any other crazy things. I need to get rid of all these parentheses. And so I'm going to have 7a to the third. Next thing I want to do is get rid of this parentheses. So I'm going to raise power to power. And so this is going to be a to the negative fifth. And in the denominator, I'm going to have a to the positive second power. Okay? Because I have a negative times a negative is going to give me a positive. Now, again, there are several different ways you can simplify this. My personal preference is because I think students make more mistakes with negative signs than they do anything else in the entire world of math. So we're going to get rid of the negative exponents before we do anything else. So I have I have 7a to the third in the numerator. I have this a to the second in the denominator. And now I'm going to move this a to the negative fifth down to the denominator and make it a positive 5. Right? And so now in the denominator, I'm going to have an a to the 7th. And the numerator, I still have a 7 and an a to the 3rd. Okay. So if I can condense my variables in either numerator or denominator, I'm going to do that. I'm going to get rid of my negative exponents. And now I'm going to finish the last part of the simplification, which is to divide. And so in the numerator, I still have 7 because I'm just left with that lovely number. But the highest power of a is in the denominator, and a to the 7th minus 3 is going to be a to the 4th. And so this is my final answer. Questions? All right. So now we start talking about adding and subtracting. And we're going to be talking about adding, subtracting, multiplying, dividing, these things called polynomials. And so really and truly, everything we've looked at so far, go back tracking just through these, notice that these things were all multiplied together, okay? So now we're going to be talking about maybe taking two of these expressions and adding them together or subtracting them from each other or even multiplying or dividing as so far and so forth as we move through this. So when we do this, we call these polynomials, okay? And we can put these all together. They don't have to have exactly the same things. The only things we can collect together are what we call like terms, right? And when we typically write final answers, we do typically write them in what's called descending order of exponents. And I'm going to show you exactly what that means. I know this is kind of wordy, so I'm going to actually show you what we're talking about here in just a second, okay? All right. So here is problem number 1. I have 1, 2, 3, 4, 5 terms up here, okay? So this is a polynomial expression because it has multiple terms to it, many, poly meaning many terms to it that I may or may not be able to collect together, okay? So what I'm going to do is I'm going to look for what are called like terms. So I'm going to look for things that look alike in terms of the variables. The numbers are not going to look alike, but the variables will. So I'm going to go through and I'm going to underline the ones that are like. So b to the 5th is like this b to the 5th. Notice the number in front of this one is a 5 and this one is a -3. So make sure the sign goes with it, okay? Then I have a b to the 2nd power. Well, there's another b to the 2nd power, and it's a -9b to the 2nd power. And then finally, I have this little b to the 3rd power that doesn't have any like terms, okay? So now when I get ready to add and subtract these, I can only collect together the ones that are like. I'm going to start with my largest power of x, which is x to the 5th power. I know these are b's. I call them x's because I just can't help it. But the largest power of b is b to the 5th. And so I'm going to start with that. And so one thing you can do is you can rewrite this. And so you don't have to. I'm just rewriting it so you can see what I'm doing. Okay. The next term is going to be my b to the 3rd because that's the next smallest exponent. And then finally, I'm going to write down my b to the 2nd power terms. And so I have b to the second power minus 9b to the second power. And so now I'm going to simplify this one step further. And so I'm going to actually collect together my like pieces. So 5 minus 3, I only look at the numbers, is 2b to the fifth. There's nothing to collect together with the b to the third. So I have negative 1b to the third. And then here I have 1 and negative 9, and that's going to simplify together to give me negative 8b to the second. Now, two things I want to point out to you on this one is the first thing is that I only collected together my like terms. I collected together their coefficients, which are the numbers in front. The second thing I want to point out to you is that my final answer is written in descending order, okay? So by descending order, I mean the largest exponent is first, the next largest exponent, and then the smallest exponent. And so that's what we mean by descending order. Okay. All right. Okay, so very similar to what we did some problems where we had to simplify some expressions, and now we're just going to throw lots of variables in here. So we're going to do the same thing. We've just got these fabulous little letters in here. And so on problem number 2, the first thing I'm going to do is I'm going to rewrite this without the parentheses. So think of this as a negative 1 in front of both of these. And so I'm going to distribute that negative 1. And so this is 3 plus 5b. And then these are going to change. So negative or minus 3b minus 9. So I'm distributing that minus 4b minus 5. Okay. And so now I'm going to rewrite this again. And I'm going to just kind of collect together. I have a 3 minus 9 minus 5. So these are my like number terms. Notice I'm taking the signs with those. Okay. And then I have 5b minus 3b minus 4b. Notice my numbers, my signs are going with these. Okay. You can skip this step if you want to. I'm not telling you you have to do that. Just be careful. Okay. So 3 minus 9 is negative 6, and negative 6 minus 5 is going to give me negative 11. I'm going to take the next part in pieces. So 5 minus 3 is going to be plus 2b minus 4b. And then finally, my answer is going to be negative 11 minus 2b. And this is it. Questions?
One question.
Yes.
Okay, in 2, why does it become a negative 9 and a negative 5? Just because you're multiplying the...
Yeah. So think of this as a negative 1 times 3b plus 9. Okay. So this is going to mean I'm going to take that negative 1 times 3b and then plus, and then I have negative 1 times 9. And so when I clean this up as best possible, I just don't like to have that negative 1 hanging around. And so this is going to be then plus a negative 9. And a little bit easier way to write that is to say simply minus 9.
Okay.
That make sense?
No, but I accept it.
Okay, well, there you go. That's all that matters. As long as you believe me, we're good.
I believe you.
There you go. I wish I could get my kids to do that easily. Anyway, to me, the short way is to say, you know what, I'm just going to change the signs on both of those things. Whatever's in parentheses behind the negative sign, we're just going to change the signs on them. That's
okay, yeah, that works. Yes. Okay.
Yep. Excellent. Very good. All right. Any other questions? Always good questions. All right. So let's move into the next one of these. Now notice on this one, I'm adding these two polynomials. So I have 3 in this one, 3 in this one. I'm going to add them together. I'm going to recognize what my like terms are. And so I have two terms with x's in them. I have two terms with x's, or x squares and two terms with x's. And then I have two terms that are just constants, okay? So we're going to start with the x squares. And so I have 2x squared plus 8x squared is going to give me how many x squares? Somebody tell me how many x squares I have. I need a number.
10.
10. Thank you very much. So I have 10x squared, right? How many x's do I have? So I've got 2 plus 8 is going to give me 10. Now in this case, I have -4 plus 9, and that's going to give me, yes, perfect. That's going to be 5 of my x's. And then finally, I have 25 plus a -55. So I got a positive and a negative that I'm adding together. And so this one is going to be a -30. Yep. Excellent. Okay. Now this next one, we've got to work with those negative signs. Okay, so when I see a negative sign in a problem, I just go ahead and rewrite the problem so that I don't have this minus and a parentheses. Okay. So in this problem, and as I do this, I'm gonna kind of color code the pieces that I have. So I have a 10. I don't know where 10 came from. I'm so sorry. I was looking at the first problem. So I have a 5x squared, right? Plus a 4x squared plus 25. And now I'm going to change the signs. Okay, here's my cheating way to do this. Okay, so this becomes minus 8x squared. And be careful here. This is going to become minus 9x, because I'm moving that negative sign through the whole thing. And then I'm going to have a minus, and that's going to become plus 55. Okay. So if you want to see it like this becomes negative 8x squared minus 9x and then plus 55. Okay, that's what that negative does to that parentheses. So now I can collect together my like terms. I have nothing that's like 5x to the fifth, so I'm just going to have a 5x to the fifth. But it's going to go first because it's my highest power of x. Okay. Now I have 4x squared minus 8x squared, and that's going to give me a negative 4x squared. I have this very lovely minus 9x hanging around by itself, so it's just going to come down here just like the 5x to the fifth. And then I have 25 plus 55, which is going to give me plus 80. And that is my final answer. Questions? All right. So, and that's why I said that was what we were going to do at the end, but we just didn't have time. So that's why we're going to continue on with this. So the rest of this is talking about, so we looked at those polynomials. We talked about exponents in the first part, and then we looked at the polynomials that we could add and subtract the like terms. Now we're going to look at the polynomials in terms of multiplying and dividing. So 4.4 is multiplying, 4.5 is dividing. We're not going to do a lot with dividing, but we're going to do a little bit. Just to kind of let you know, anything you do with real numbers, you can do with polynomials, okay? So if you can add, subtract, you can even make fractions out of these lovely creatures. We're not going to right now. Well, a little bit of fractions because we're going to be dividing, but it'll be friendly fractions. So, okay. So here's where we're going to, and if I was in class, I would be saying, okay, I'm going to hand everybody a piece of paper. And that means everybody would get this piece of paper. So when I do what's called the distributive property, I am literally going to distribute this to every single solitary piece of this. Now, we did this a little bit with numbers, but we haven't done it with variables. And so now the same thing we did with numbers at the beginning, now we're going to do with variables. And so I'm going to write out an extra step in here. And guys, honestly, if you need it, then that's amazing. And if you don't, then that is okay also. So you have some choices. I don't give you a lot of choices in this world, but you get a few. So I'm going to take 6x to the third. That's an x to the third. And I'm going to multiply it by 2x squared. Okay. And then I'm going to have minus, because there's a minus sign here, and I'm going to have 6x to the third times 5x, because that's the next part that's here. And then I'm going to have plus, because that's what's there. And I'm going to have 6x to the third times 9. Okay. So I multiplied this times each piece. It's all added and subtracted to begin with, but 6x to the third was multiplied times the whole polynomial. So I have to take 6x to the third times each piece. Okay. And if you can do this in your head and skip down to the next line, like I said, that's amazing. That's fabulous. Okay. But if not, it's okay. So I'm going to multiply my pieces. And so 2 times 6 is 12. And x to the third and x squared is x to the fifth. Minus 6 times 5 is 30. And I have x to the fourth. And plus 6 times 9 is 54 times x to the third. And that is my final answer. Questions? Okay, so this next one, we're going to do exactly the same thing, except that I have 2 parts that have to be multiplied by everything. So I have this 6x that has to be multiplied times each piece, and I have 9 that has to be multiplied by each piece, okay? So I'm going to start with the 6x. So 6x times 9x squared plus, because there's a plus sign here, 6x times 2x plus, because there's a plus sign there, 6x times 9. But I'm not done yet. I've only multiplied the 6x times everything. So now I have to go through and multiply everything by 9. So plus 9 times 9x squared plus 9 times 2x plus 9 times 9. So 6x is going to multiply by everything, and then 9 is going to multiply times everything. Okay. So I end up with 2 times 3 or 6 terms here. That's just what's going to happen. Okay. So now I'm going to simplify it, but I wanted you to see all of the pieces. Again, if you want to skip this step and actually just do the multiplication, that's fine. That's your prerogative. Okay. So this is going to give me 54x to the third, because I have to look at my variables and my numbers, plus 12x squared plus 54x. And in the second part, I'm going to have plus 81x squared plus 18x plus 81. And now I'm going to collect together my like terms. So again, I don't have anything that's like this x to the third. So I'm just going to write down 54x to the third. I have a 12x squared and an 81x squared. And so when I add those together, 12 plus 81 is 93 x to the second power. And then I have a 54x plus an 18x. So I'm going to add 54 and 18, and that's going to give me 72x. And then finally, I just have this plus 81 hanging out at the end, and that is my final answer. Lots of pieces. There's no reason to get into a rush. This is not a race to see who finishes first. It is a competition to see who finishes best. Not really, but anyway, it's a personal competition, but it is certainly not a race to see who can do this first. Questions? Somebody asked about FOIL. FOIL, we are going to see in just a minute. FOIL is an acronym for, or a mnemonic device for multiplying together some things. And so we're going to look at that in just a second. All right. So let's move to this. See, you had perfect timing on asking about FOIL. Okay, so FOIL is, it's a mnemonic device to help you remember the product of two binomials, okay? In a binomial, you have two terms and two terms, okay? So when I multiply two binomials together, I can use the distributive property, or I can give it a name. And the name for the distributive property with two binomials is FOIL. And what it stands for is it stands for first. So this is first. And then outside. So outside. And then inside. So inside. And last. Okay. So first, outer, inner, last. First, outside, inside, last. Okay. So here's what we're going to do. We're going to multiply the first two terms together. So I'm going to have 3b times 4b. We'll clean that up in a minute. Okay, that's my first terms. My outside terms have a plus sign here, so that's going to be a positive 3b times 5. My inside terms are going to be a negative 3 times 4b. And then my last terms are going to be negative 3 times 5. And so now let's clean this up. So this is going to be 12b squared. And then I'm going to have plus 15b minus 12b minus 15. And I have two like terms in here, so I'm not quite done. So I have a 12b squared. These two are like terms. They both have a b on them. So I'm going to collect them together. So I have plus 3b and minus 15. And that is my final answer. Okay, FOIL, yay! Questions? All right, so I want you to try number 4. And if you get an answer, I think you can type this in the chat. If you get an answer, type it in the chat for me. Maybe I have to be a little creative, but it'd be okay. I think I can tell you this. How we doing? If you're stuck, you can look at the screen, try to get you started. If you want to type an R squared, you can do R with a little caret. That means R squared. So for those of you who are just dying to type in your answer to me. Oh, that's so pretty. Yes. That's a secret. There is time you start finishing. Oh, yay, that's so pretty. I'm seeing all these beautiful answers come flying in. I'm a little worried about how I'm going to chat with people in the fall. So maybe I want to do this in the fall. Oh, let me get at least one more person give me an answer. I think some of y'all going to sleep. Keep going. All right. So if you've gotten to the point you're multiplying things together, you just not want to send me an answer. It's okay. All right. So R times R is going to give me R squared. I'm going to get negative 8R plus 10R in the middle. And then 8 times negative 8 is going to be a negative 80 here. But I can collect these two middle terms together. So my final answer here is R squared plus 2R, because negative 8 plus 10 is going to be 2, and then minus 80. And so here is my final answer. And several of y'all put that in there. Excellent. Very good. Questions? All right, you got this. So let's do one more of these. So FOIL works because you've got 4 terms and FOIL has 4 letters in it. And so when I do a 2 binomial times a binomial, so that's 2 times 2, and that's 4. So like I said, it's the same thing as the distributive property. It just has a special name to try to help you keep this organized. Okay. So I'm all about the little mnemonic devices that help you remember how to do these things. That's great. So, okay. So we're going to do same song next first. So we're going to do 5C. Make sure you're careful about putting C's in your answer, R's in your answer, B's in your answer, and not X's. I'm terrible about that. Okay. So first, and then outside. So I have 5C times 5. Inside is minus 3 times 6C. And last is minus 3 times 5. So like term collection, 30C squared plus 25C minus 18C minus 15. And so as I collect these together, descending order that I write my answers, this is going to be 30C squared. My larger of my two terms is my 25, so 25 minus 18 is plus 7C, and I can't do anything with the minus 15, so I just have minus 15. And so this is my final answer. Questions? How are we doing? I know it's math, it's Wednesday. Hey, we're halfway through the week. Yay! All right. So I want you to be super careful with problem number 6 because it doesn't work exactly like the last problems we did where we squared things. So when I square something, it means I multiply it by itself. So before you do anything else to this problem, I need you to see this square and I need you to rewrite this as x minus 4 times x minus 4. That's it. I just need you to rewrite it. And then I need you to multiply it out, okay? You always want to write this as the product of two things. It keeps you from doing the craziest mistakes that you could possibly do. There's no shortcut. No, there's no good shortcut. Okay, so now we can FOIL it. So we can do first, so x times x, okay? Outside, so we have x times negative 4. Inside, so I have negative 4 times x. And last, so I have negative 4 times negative 4. Now watch what happens. I clean this up. X times x is x squared. I have minus 4x. I have minus 4x. And I have plus 16. Well, I got two of these guys. And so my final answer then is going to be x squared. I get negative 4 minus 4, or negative 4 plus negative 4. I have two of these negative 4s. And so that's going to give me a total of negative 8 x's, and then plus 16. And so this is my final answer. Questions? I'm going to do the same thing with number 7. The very first thing I'm going to do, though, is I'm going to rewrite this. Okay, if you don't rewrite this, you are going to make a fatal math mistake. It may not be fatal in the rest of the world, but it is going to be a fatal math error if you do not rewrite this as the product of two binomials. Period. Done. Okay, so I've made my peace with that. Okay, so this is going to be 2x plus 2y times 2x plus 2y, and now I can FOIL it. So first product, 2x times 2x, right? Plus 2x times 2y, okay? Plus 2y times 2x, and then plus 2y times 2y. Cleaning up the mess, this is going to be 4x squared. My second term is going to be plus 6xy. I can't do anything with those, so I just multiply them together. My next term is going to be 4xy. How do I know to write xy as opposed to yx? Oh, I don't. I just put them in alphabetical order because they look nicer. And then it also makes me consistent, so it's easy to see what my like terms are, because I do have two like terms there. And then finally, I've got 2y times 2y is 2 times 2 is 4, and y times y is y squared. So I do have two like terms here in the middle that I can collect together. So this is 4x squared. My two like terms, I have 6xy plus 4xy. And so this is going to give me a total of 10xy. And then finally, I have 4y squared. And so this is my final answer. Now, notice on 6 and 7, I was multiplying something by itself. On 8 and 9, I am not. So they look very similar, but they are not the same things, okay? But I don't need to rewrite anything. I'm still going to FOIL this. I'm still going to multiply them together, right? So questions about 6 and 7. All right, I want you to FOIL number 8. Y'all take a second and multiply number 8 out. And if you get an answer, type it to me in the chat. When you get an answer, not if you get an answer. When you get an answer, type it to me in the chat. Oh, that's so pretty. You're making me very happy. Yes, the simple pleasures in life. Yay! I can't type on this. One of my favorite things about MyList Plus is when you get questions right on the homework, it gives you this marvelous, great, excellent, fabulous, fantastic. So I'm trying to come up with new words to tell that. Okay. All right. So, right all over the place. Quit. These are showing up. Okay. All right. So let's FOIL this out. So the product of the first terms. So I'm going to have x times x. The product of my outside terms is going to be plus x times -5. So watch this, be very careful. And then I'm going to have plus 5 times x. And then my outside terms is going to be, my last terms is going to be plus 5 times -5. Now I did this in this particular order so you can really see what's happening here. This is going to be x squared. This is going to be minus 5x, and then I have plus 5x, and then I'm going to have minus 25. Well, look what happens. My negative 5x and my 5x, whoosh, gone. So I am left with x squared minus 25. And that is my final answer. Done. My middle terms went away. That's so cool. That's actually really cool. Okay. Notice that I have exactly the same thing. I have opposite signs. That's kind of a predecessor to some things we're going to talk about later. Okay. All right. So let's do this one together. So again, you might kind of suspect what's going to happen. If you starting to suspect things and you suspect correctly, then you're starting to make some leaps and jumps and connections, and that's amazing. And if not, it's okay. They will come, I promise. Okay, so we're going to start with our first terms. So 3x times 3x. Our inside terms, or yeah, no, our outside terms, FOIL. Oh, okay, so 3x times negative 4y squared. We're multiplying these, so that's okay. And then our inside terms, so 4y squared times 3x. And then our last terms, so plus 4y squared times 4y squared. And so now when I simplify this and clean this up, I'm going to get 9x squared. I'm going to get minus, because I'm multiplying, 12xy squared. I'm going to get plus 12xy squared. Remember, I can't do anything with those non-like terms other than just multiply them. And then I have 4 times 4 is 16, and y squared times y squared is y to the 4th. Notice my middle terms disappear. They cancel out. And so my final answer is 9x squared plus 16y to the 4th. And that is it. Oh, amazing. Questions? Okay. All right. So we talked about adding and subtracting and multiplying, and now we're going to talk just a little bit about dividing. There's so much we can do with dividing polynomials, but right now we really just want to do what I call some simple division problems. And so if you click on section 4.5 in the e-text or whatever, there's so much more we can do with division of polynomials. But like I said, we're really just going to concentrate on dividing by a single term. So one thing we can do, and that's what we're going to do here, is if we divide by one term in the denominator, so we've got just a 2 down here, then we're going to rewrite this as fractions so that the denominator is under each piece. So we're going to split this into, we've got 3 terms in the numerator, so we're going to split this into 3 separate fractions, each with this denominator of 2. And so I'm going to rewrite this as 12x to the 4th over 2, and then minus, because I've got a minus here, 10x to the 3rd over 2, and then plus, because I have a plus here, 6 over 2. And we're going to simplify it like this. Like I said, there's so many different things we can do, but we're just going to divide by this one single term, okay? It may have multiple pieces, but it's just going to be one term in the denominator, all right? So now we're going to simplify this. This is going to give me 12 divided by 2 is going to be 6, and I still have that x to the 4th because there's nothing else to do with that, okay? So I just have a number. My variables are not going to change. Minus 10 divided by 2 is 5, and I keep my x to the 3rd. And then finally, 6 divided by 2 is plus 3. And that's going to be my final answer. In this problem, I'm just dividing by a whole number. In the next problem, we're going to introduce a variable in there, but it's still going to be a single term in the denominator that we're dividing by. Okay? So in other words, the things in the denominator are not added and subtracted. Right? One more problem, and then we're going to be done. I told you we're going to finish a little bit early today, right? So here, my single term has a number and a variable, all right? So we're going to split this again into 3 separate pieces. So we'll start with 24 m to the third divided by 4 m to the second, and then we'll have plus 16 m to the second divided by 4 m to the second, and we're going to simplify each of these, and then plus 16 m divided by 4 m to the second. So we have to write each piece of this as a fraction over this one denominator. And we can do that as long as the terms in the numerator are added and subtracted, and I have a single term in the denominator. So now we're going to simplify, and so now we have some variables to simplify also. 4 divides into 24 6 times, and so m to the third divided by m to the second leaves me with an m to the first. I don't have a denominator on this. My denominator is 1, but I'm not going to write that 1, okay? So if your denominator is 1, you're not going to write the denominator of 1. If the numerator is 1, we have to write the 1 in the numerator. Okay, but not the one in the denominator. And all these crazy rules we have, right? So the second part of this, my m squares divide out completely. I have the same thing at the top and the bottom. 16 divided by 4 is 4, so I just have plus 4. And then finally, and this one's a little bit stranger, my 4 divides into my 16, and it leaves me with a 4 in the numerator. I have m divided by m squared. Highest power of m is in the denominator. 2 minus 1 is 1. And so this is my final answer. Yes, I can have a 6m plus a 4 plus a 4 over m. There's nothing wrong with that. Absolutely nothing wrong with that. Questions? Okay, guys, this is all I have for you. This is the end of chapter 4. And so here's my suggestion to you. I will stick on the WebEx session for at least, at least until 11:45. If you want to stick around and ask me questions, if you want to go work on homework and feel like you can come back and ask me questions, then feel free to do that. If you just want to go work on homework by yourself, that's okay also. Don't forget that you do need to make sure you finish up homework number 3, and then you can start on homework and quiz number 3, and then you can start on homework number 4. So, but this is the material for homework number 4. So we will knock out part of chapter 5 tomorrow, and then the rest of chapter 5 on Friday. It's going to take us 2 days to do chapter 5, lots of stuff in there, and then that will be the last of the material for test 2. So we're rocking along. So if you got questions, stick around and ask them. Otherwise, have a lovely rest of your day. Bye.
Hey,
Yes.
can you explain one more time that 16m over 4m? How you got that?
Hang on half a second. These people are beeping off and they're making noises, and I couldn't exactly hear your question.
Okay.
Okay. Perfect. Okay. Go for it again. Tell me one more time.
Can you explain one more time that 16m over 4m, how you got that? I know 4 goes into 16. Okay.
So think about it like this. So think about it as 16 over 4 and then m over m to the second. Okay. So like you said, you know that 4 divides into 16, and this has actually just 4. So 16 divided by 4 is 4. And then this, I have m to the first divided by m to the second. And so remember on the first page of this, we said, okay, wherever the highest power of the denominator is I'm going to subtract. So 2, think of it like this. This is m, and then m to the second is m times m, right?
Right.
Okay. So I have 4, and this m divides into one of these and leaves me with a 1 over m. And then I'm just going to rewrite this so 4 is in the numerator. Does that make a little bit more sense? Or you can think of it as subtracting those exponents.
Oh, yes. Okay. I wrote that down wrong. That's why I was so confused.
Okay, that makes a difference too.
Yeah, it does. Okay. All right. Now, one other question. Back in the first part of it, and my page is cut off at the top, so I can't quite see the question. 1, 2, 3.
I can just keep going back until you.
Fifth page of that first part. It's the one that has negative exponents. And it has the question. Yes. Okay. Wait, let me see if that's it. Yes. Okay. On D.
Okay.
Why does the second part of that on